giusto sul
check also streaming. Okay. So, good afternoon, everybody. It is a pleasure today to have here with us Professor Norbert Fuhr from University of Duisburg-Essen in Germany. It is, Norbert does not need any introduction. He is a recipient of the Sultan Award. He did seminal work in our field on probabilistic IR models, XML retrieval, interactive information retrieval, and he also contributed a lot to our community, organizing dark seminars, schools, and so on. So it's really a pleasure to have Norbert here today for a talk entitled Negation, Contradiction, and Credibility in Information Retrieval.
Okay, thank you very much for the kind introduction, Nicola. Yeah, so today I want to talk about the issue of negation and related problems. So I'll start with a few motivating examples. So when we search for negative statements in IR, for example, I like muesli, but without sugar, or you want to buy a new mobile phone without a contract, or you need a new laptop, what just like me, you want to run Linux on it, so you don't want to pay for Windows. Now, how do you do that? With current IR systems, you formulate the query, muesli, not sugar. But then there is a document where in the text you have all our muesli are sugar-free, but this document is not found because of the not sugar, which means the term should not occur. Similarly, you say mobile phone, not contract, but then in the document you might have we sell mobile phones with and without contract. Again, would be an answer, but the query does not match. Or the same again with the laptop. XXX is a model without Windows, save 99 euros. Well, you cannot save this money because the document is not found. So this means that there's no appropriate support for negative statements in current systems. So it does not really work properly. So maybe some logic can be of help. Since there is a not, obviously, we should have a look at what's happening logically. So the classical view in IR is you have a query, you search for term T1 and T3, and if you have a document with the terms T1, T2, T3, then in retrieval, you're just looking for those documents which contain all query terms. Now, in the logical view, this can be interpreted, your query is T1 and T3, and the document is T1 and T2 and T3. And now documents are an answer if they imply the query. That's the logical view on IR. And of course, we all know about weighting. Where does the weighting come into play? Well, here Reisberg wrote his seminal paper that IR is based on probabilistic inference. And the important thing is that probability of D implies Q should be interpreted as the probability of Q given D as the conditional probability, not the probability of the equivalent in classical logic that D implies Q is implicit to not D or Q. So now we have weighting, so we can forget about weighting for a while. But now about negation. How does negation work in the logical view? So here's our query, muesli and not sugar. Now the document contains the term muesli and raisin and chocolate. Does the document imply the query? No, obviously not. This way, the implication does not go through. What do we have to do instead? Well, we construct a different document representation which includes all the terms in our vocabulary. Those terms not contained in the document, they are all negated. Muesli and raisin and chocolate and not sugar and not nut and so on. And now suddenly the implication goes through the document. A modified document representation now implies the query. Now, what I've done here is based on the logical principle of the closed world assumption, assuming that everything that's not explicitly true is assumed to be false. Or sometimes it's also called negation as failure for those who have learned prologue, for example. That's the basic principle of negation in prologue. And but the question is this really a reasonable approach also suitable for IR? So because there's an alternative approach, instead of a closed world, I can also assume an open world. And so the closed world is in the database area, but maybe in IR we need something different. Assume the query, does Phil Smith work at the University of Padua? But the database approach would do a look up in the employee database. And if Phil Smith is not found, then we can imply this is false, this statement. Phil Smith works at the University of Padua, that's false, so we can be sure that he doesn't work here. But if we don't have access to the database, we can do a search on the web pages. Now, if we don't find him on the web pages, does this imply that he doesn't work here? Well, we just don't know. Maybe he works here, but doesn't have hasn't created a web page on his own. So this means in that case, we only can infer we don't know, maybe or maybe not. So we cannot definitely say he doesn't work here just because he doesn't have a web page. So this means that the closed world assumption, assuming that everything that's not explicitly true must be false, is not appropriate for information retrieval. Why is that so? Well, because on the one hand, we have an uncertain and incomplete representation of the document content, and of course also of the knowledge. The documents available do not describe all the knowledge that's available. That, for example, Phil Smith is working here. So this means that instead of a closed world assumption, it's more appropriate to work with an open world assumption in IR. And this allows for unknown knowledge and also for proper handling of negation. So how does this look like? Now with the open world assumption, now we have 3 documents. First one contains the terms muesli and sugar, the second one muesli and raisin, and the third one muesli and not sugar. And now I'm looking for muesli and not sugar. Now, in this case, obviously in the case of D1, this is obviously false, not an answer to the query. In case of D2, I just don't know, just because sugar is not mentioned explicitly, it might nevertheless be the case that it's contained. For example, in Germany, they use all kinds of strange words of sugar variants or so in order to avoid the word sugar in product description. Probably you tell it's the same because it's in the EU. And so we just don't know. And only in the third case, when it says explicitly muesli and not sugar, then it's true. Okay, another related problem now has to do with aggregating information. And this is especially when we're dealing with reviews nowadays. So I'm no longer talking about single documents, but we want to aggregate information. For example, you are thinking about buying a new hard disk or so, you go to the online shop and there are hundreds of reviews for a specific model. Now, how can you aggregate the knowledge instead of just looking at the star rating? Maybe there are certain, you're only interested in certain aspects, and some people might say that this hard disk looks ugly from the outside. So for some people that might be criterion, for others they just don't care. So you want to aggregate the opinions from different reviews. And here now we have positive and negative points mentioned by the different reviews. So here we have, for example, T1 and not T2, and in the third one and not T3. And now, if we aggregate the information from these reviews, then we say, okay, T1 is true because all the reviews say T1 is true. For example, has a high performance, high throughput. T2, if you are asking for T2, then we can see, yeah, it's obviously false. There's only one review talking about it, and they say T2 is false. And what about T3? Well, now we have here inconsistent knowledge. T3 is positive in the first review and negative in the third review. So that's the price we have to pay once we allow for explicit negation. We have to live with contradictions. We have inconsistent knowledge in that case. And when we are looking for T4, yeah, then it's just unknown. This aspect isn't mentioned by any of the reviews. And when you look at this, also related problem is credibility. The question is, do we believe in the honesty of all the three and competence of all three reviewers? Or maybe some of them, like I also experienced, they got a voucher along with the product. They got a voucher for, if you do a positive review of our product, you get a refund of 10 or 20 euros. So some of the Chinese suppliers, when they have new products, so they do this in order to get positive ratings in the beginning. So credibility might be a problem. And there are many studies dealing with credibility and how to estimate that. And so we have not really worked in this area. The approach that I will be presenting is able to consider also credibility. That's a basic requirement when you, or just a follow-up problem, once you allow for contradictions, then you also need to consider credibility in some way. Okay, now all these problems, this is not really new stuff. It's very old stuff. I noticed, well, it's exactly 25 years since we talked about this. At that time, everyone was talking about digital libraries and thought, yeah, what about if two newspapers talk about the same event, but there is some contradictions in that. How can combine the information of the two sources or so? So we had the theoretic model, but the problem at that time was, yeah, we just didn't have the indexing method for actually identifying the negation in the statements in the documents. We started already before, so this was part of the EU-funded project on multimedia retrieval. Parallel with our project submission, the submission of our proposal, there was a second proposal that dealt with the indexing of multimedia documents. And as everyone knows, well, in principle, indexing comes before retrieval. But the EU decided they had only money for one of the projects, so they funded the retrieval project. Good for us, because we were only participating in the retrieval project, but bad for the field as a whole, because no multimedia indexing was available. And we also were struggling in our project. Where do we get a kind of application? So one of our partners, they did a lot of manual indexing in the end in order to apply the methods. So the indexing is a big problem. Fortunately, nowadays we have better methods in natural language processing. So we have now in certain areas, as you will also see, we are able to identify negated statements. And it's not only about identifying, but recognizing the exact statement and find out what's the negation of this statement. So how does the natural statement look like in order to identify the positive versus the negated statement. So in the following, I want to show how we applied these methods to user reviews, and the statements that we are regarding here are predefined product or service aspects. So we define the aspects for a product type or for a service type regarding the domain of hotel reviews. And then we just look, are people talking positive or negatively about hotel staff, for example, or the cleanliness of the room or so. So these are the aspects we are regarding in the following. So that's our application. We looked at user reviews, and the goal was to do an aggregation. As I said already before, you might have hundreds of reviews for a single service or product, and besides the contradictions, of course, then you also have a problem of credibility, and you have a problem of missing information that many reviews will not mention all aspects, so you need a way for dealing with this issue. And in our approach, we considered two types of logic-based models. We were focusing on four-valued logic, about which I was talking before. And as an alternative approach, we also regarded subjective logic, which was explicitly designed with the goal of modeling this type of situation where you have limited belief in certain sources. Okay, so the framework was four-valued logic, and that goes back to Belknap. We called it relevance logic with the four truth values: true, false, unknown, and inconsistent. And what we did, that's also not that new. We also did this in the late 90s. We developed a probabilistic version of Belknap's logic. So for single reviews, a review cannot contradict itself, at least it shouldn't. Otherwise, credibility would be zero, and then we can ignore it. So a review can, in a review, a certain statement can either be true. For example, the price of the product is good, and we can also assign a value. For example, here we are 60% sure that this user is positive about the price, or there is a negative statement about the battery where we are not very sure. So here the weight is just probability is 20%, or another aspect is not mentioned at all. In that case, the unknown probability is 1. And we also assume that always then here in these cases it's filled with unknown up to the probability of 1. So, and now the problem comes, how do we aggregate this information from different reviews in the probabilistic case? And here we have to distinguish two cases, namely first the disjoint case, that we say, well, the reviews actually, they refer to different instances of an item. For example, if some buyers of a hard disk complain that they experience a disk crash, this refers only to their specific instance, but this doesn't mean that all instances of this hard disk will experience a disk crash. So this means these are just disjoint cases. So this, we all know this transfer just into a certain percentage of devices. You could say, well, maybe 1% or so of this of the devices sold, they experience a disk crash. And how can we model that? In our case, well, we just assign different credibility values to the different instances such that they sum up to 1. Or we can also say, well, the sum can also be smaller than 1. If you do not fully believe in all the reviews, then the sum can be also smaller than 1. But the point is that these are just disjoint cases. Now, and in that case, now the two statements would, well, one positive and one negative here with the given probability, then would be aggregated in such a way that you just multiply the credibility times the probability of the truth value. That would give you 0.49 for true and 0.5 times 0.3, so 0.15 for false, and the remainder is unknown. Now we come to the more interesting case, where we probabilistically the independent case where the reviews are regarded as independent comments on the same instance. So, for example, if people talk about the content of a book, so it's obvious that all buyers of this book got the same content. so nothing can be broken in few of these books and working fine in the others. It's the same content. So in that case, we cannot regard this as disjoint events. Rather, these are independent statements about the same thing. And so for each single review, we can assign a credibility between 0 and 1. And if when reviews are overlapping but have different truth values, then we have a contradiction. So if we have true and false, like in this case here, then this leads to inconsistent knowledge. And then, for example, here in this case, we have then this probability distribution of 0.44 for true, then 0.08 for false, and 0.35 for unknown, and 0.13 for inconsistent. So I don't want to go into the details of the weighting formulas. It's written in the paper in case you are interested. But it's just different formulas. The basic idea is that you have independent events, and in that case, you may have inconsistent knowledge resulting from contradiction. Whereas in the disjoint case, you cannot have contradictions. So, in addition, just a few words about the subjective logic is also probabilistic logic already from the beginning. The idea is to have an approach that's able to deal with uncertainty and subjective opinions. And it talks about belief, disbelief, and uncertainty. So in principle, it only has 3 truth values. And it also supports disjoint and independent cases. That's considered by 2 different fusion operators for combining statements from different sources. But I don't want to go into the details of this approach here. Just as saying it's not the only approach that's able to deal with this type of problem. Now, we performed experiments on a data set from hotels from booking.com. We had roughly 840,000 reviews on 11,500 hotels. On average, we had 173 reviews per hotel, so a good basis for applying our approach. And already the reviews themselves, they are aspect-based. So when you have the reviewing form for the end user, you explicitly have mentioned the different aspects, and users, they can rate each aspect on 4 different grades. And in addition, they have separate fields for positive and negative comments. So we don't have to bother with sentiment detection. We just have to identify which aspect does this term belong to. For example, when he talks about friendliness of the reception, then we have to recognize, yeah, this refers to the hotel staff, obviously. And so what we did here, we had no access to the individual ratings. We just have access to the text, to the individual text, but the individual ratings are not accessible. And what's accessible is the overall rating of a hotel, and we use that as a ground truth. So you can see the cleanliness here is 9.3, the comfort also 9.3, or the free Wi-Fi was only 8.6. And now this is the ground truth that we try to estimate based on the textual content of the reviews. And for doing that, so we have these aspects, but in order to identify the corresponding statements in the text, we applied clustering. So for each aspect, we created a set of terms. So by some clustering method, for example, when we have cleanliness, the text might contain the word clean, unclean, smelly, or for location, we found location with the K or central and so on. And so just by an appropriate clustering method. So this way we are now able to identify if the text talks about certain things, to which aspect does this belong to. In our experiments now, we consider 3 different indexing approaches. Since already in the reviews, we have different fields for positive and negative comments. In principle, we are able to calculate positive and negative scores from that. And for doing that, we had the traditional IR indexing, means we just index all the positive comments for an aspect. Then that gives us the positive weight, and then we index all the negative terms occurring in the negative comments, then we get the negative weight in that case. And then we apply the subjective logic for aggregation and the 4-valued logic according to the approach that I outlined before. So a bit more detail. So in principle, we only regarded single aspects for our queries, artificial queries, so to say. Each query is just a single aspect. And for that, in principle, we define 2 propositions, for example, clean and not clean. And a review supports now one of these propositions. Either it states the hotel was clean, or it says the room was very smelly. That would be a negative supporting the not clean statement. Or it could be the case that the review doesn't mention cleanliness at all. This would be modeled in our 4-valued logic as unknown. Now, given the first the query, the next is the credibility assignment. So in principle, now we have to assign a credibility to each of the reviews. And unfortunately, in Booking.com, only verified users are allowed to write reviews. Only if you book this hotel, then later on you are allowed and even encouraged to write a review about this hotel. So this means that in that case, we can assume the same credibility value for all reviews. We do not set the credibility to 1 because, you never know with the reviewers if this is really 100% correct, what they said. So we choose value smaller than 1. And in principle, you could, in the ideal case, would be credibility 1, but as I said, we chose value smaller than 1. And then we also considered the disjoint case. So in that case, we assumed a full uniform probability distribution over all the reviews. In that case, we assumed 1 divided by the number of reviews was the credibility of a single review. And next, we had to extract the truth values from the documents. That's based on the supported proposition. And for that, we had to map the reviews with the aspects, like I said, based on the term cluster. We just check which terms of the current cluster, of the current aspect cluster occur in the positive or negative part of the review, if they occur at all. And then we also applied 3 different weighting methods, either simple TF model or TF IDF or BN25 weighting. And so once we had the weights here from for the different reviews, then in the next step, we did an aggregation of these truth values. So then here we have, like in the examples that I showed before, then for each proposition in the 4-valued logic, we have probability for each of the 4 truth values. And then the final step was, since our ground truth is score for each aspect of a hotel, we have to estimate the score. So, but what we are given is just the probabilities of the truth values. And so for the mapping onto the scores, we tried different regression models, but we mainly focused on linear regression because the sample in the end wasn't that big, or the other methods have really performed much better, even worse than linear regression. So it turned out that linear regression does a reasonable job, and it's also more transparent, as we will see later. So we have this quadruple of probabilities for the 4 truth values, and then via linear regression, we compute a score from that. So what we did, just to recap, we index positive and negative review text separately. Then the aggregation was logic specific for traditional indexing, subjective logic, and 4-valued logic. Then we have the quadruple of truth values, or only 3 values, and then we performed linear regression, and then we computed R² for the goodness of the fit. And so here we have the result. So here we have the 3 different approaches, and now we have 7 groups of columns for each approach. So each group of columns refers to one aspect, and then we have the 3 indexing approaches. These are the columns or the bars for each aspect. Blue is the TF weighting, red the TF IDF, and green, yellow is it. I'm looking from the side on the screen and I see strange colors, but you see it hopefully correctly. So yellow is BN25. And now what you can see here, these are the traditional methods, and you can see that here the 2 logic-based models, the color and the bars are higher, so they are doing better than the traditional indexing. And then if you also compare the subjective logic versus 4-valued logic, then also 4-valued logic is performing slightly better than subjective logic. And when comparing the different weighting methods, it turns out that here for logic-based models, the TF weighting, so the blue bar, is the highest, so that's the best weighting method here. And well, now the previous charts, they were for the independent cases of the two logic-based approaches. So here we have a comparison for the four-valued logic and the charts for the subjective logic are very similar, where we compare the independent versus the disjoint case, and we find that independent is much better than the joint case. So in that case, obviously, we should regard the reviews as independent events, and users, in principle, they evaluate hotels also in general and not particular instances. So, for example, you say, okay, maybe some users, they got a room that was not in good shape, or on that day they visited the hotel where the staff, some people from the staff were a bit unfriendly or so, but that is not the right approach, obviously, here. And it's better to regard the reviews as independent opinions about the same product or service. So here comes a more detailed analysis where we look at the regression factors. So here we have blue is the weight of the true statements, and red for the negative comments, and yellow is for the unknown, if this aspect is not mentioned at all. And yeah, of course, the negative, they have a negative weight, and the blue ones are positive. That's what everyone could expect. But the interesting thing is that negative reviews have stronger influence on the overall score than the positive comments. But this also has been observed by others before, who studied the influence of positive and negative comments in reviews. But also our four-valued logic approach confirms this now, that the negative comments have just a stronger influence on the overall score of the product or service. And the other interesting thing is that unknown, so if something is not mentioned, this in most cases has a positive influence. So if people are not mentioning a certain aspect, usually this means this was okay, not perhaps a big mentioning, but nothing that disturbed the users. So we see that with this combination of four-valued logic and linear regression, we also get some insight in what's actually going on here. Okay, so this was based just on the comparison with the overall scores. That we just compared the outcome of our regression with the actual score. But the question is, is the whole approach of any benefit for the end user? So how can we do a user-oriented evaluation? Well, we built the first prototype of user interface. I have to say already, this is nothing you can show to an end user. This was just for illustrating what we can do in principle. So here on the top left, we have the traditional view of the distribution of the judgment over the different tasks. And then what we have in addition is here. You can select an aspect you are interested in, or in principle, you could select more than one aspect, and then you are only shown refused talking about this aspect. And then refused, they have text here showing which aspect is this review actually talking about. In addition, you can also do a search. Now within these reviews, show me passages talking about charging, and then these corresponding aspects are highlighted. Then in addition, here you have the overall distribution of the truth values. Already when we discussed this with our colleagues from the Social Science Information Center, who are computer scientists, they had problems understanding this kind of graph or so. So the probability distribution over 4 truth values. That's nice for us to understand what it means, but for users, it's very difficult. And then users also have the possibility to select certain reviews, further restrict the reviews that are shown by clicking on the stars here, saying, well, I'm interested in reviews that talk very positively about the battery aspect, or 5 stars here, negative, that talk very negative about the battery, and so on. So these, in principle, are the possibilities what we could do, but that's still some way to go. So what we are currently doing is, on one hand, we are checking this, we are testing this highlighting that users select a certain aspect, and the reviews talking about this aspect are highlighted. None of the other information is shown, and then we ask them what they learned about this aspect from the highlighting. And the other thing we are doing is that we compare the ranking, the traditional ranking, with the ranking based on the 4-valued logic, and let users judge about the answers that they get. They do not see, so we merge the outcomes of the 2 approaches, and then the user judge about the individual products, and then the hypothesis is that ranking based on 4-valued logic is better than ranking on 2-valued logic. That's they are about to start with the user-oriented evaluation. Okay, so let's come to the conclusion. I've presented a transparent logic approach for handling the following problems. So for dealing with credibility, but as I said, credibility has to come from somewhere else. There are enough researchers dealing with credibility. For dealing with contradictions and with missing information. So in the future, we will spend more work indexing and weighting methods. So currently we are studying the use case of product reviews. We are focusing on laptops for the moment, but clothes is also a product type we want to address. And we have done some work already. And then the indexing, so we have reviews from Amazon. Here we have to detect also the sentiment with respect to the aspect, in addition to what we did in the hotel domain. And then we will do user studies with real user queries, and of course also the user interface. As I said, what I showed you is certainly not something you give to the end user, but how should the actual user interface look like. So that's also subjective. So that's nice. Okay, and that's it. Thank you for your attention.
Thank you very much, Norbert. Questions? Maria?
I guess you mentioned that towards the end, but
Yeah.
when I saw your user interface, I immediately thought about aspect-based emotion classification techniques that basically they do the same thing in terms of outcome of the process, but basically the four logic values might be for emotions, and then you have the aspect, which is the battery, and you might use those techniques and get, but to similar conclusions. But I don't know about contradictions in that case, because I did a little work on that. Not explicit handling of that. So maybe I don't know.
The point is we have to index single reviews, but contradictions only can come into play when we want to do the aggregation, when we want to aggregate the opinion from different reviews.
Okay.
So in that, for indexing single reviews, maybe the approach you mentioned
so maybe
might be interesting. In principle, I could imagine
that maybe would be a good follow-up of this.
Yeah.
This is what I immediately thought about when I saw that. So just suggest hypothesis.
Maybe you can email me references. So that would be good.
So I understood that you haven't dealt yet the credibility aspect, and you're not.
No, there are so many other studies on that aspect. So we just take the outcome of their work and plug it into our approach.
So may I ask you what kind of approaches are you considering for this aspect?
We haven't looked much into that. But some studies, they just look at the language of individual reviews. But some years ago, we also had a master thesis, which also looked at the other reviews done by the same user, also something that normally you cannot see also. And that was a major outcome of this study, just by having knowledge about which other reviews the user has done. It's easier possible to identify fake reviews, for example. Someone has reviewed a large number of products or so, that becomes incredible. And so he did a very small user study where his users just had to look at the review and judge, does this look credible or not? And it turned out that just in this case, some user did lots of reviews or so. The single review was regarded as credible, but with the information what this user had done elsewhere, it was quite clear that this was a fake.
Thank you.
I have a couple of curiosities. First one is you were showing that there were, negative reviews were impacting much more. So my question was, in terms of balance, how many positive and negative reviews were you were using? Because usually, from my experience, there are many negative ones than the positives.
Yeah, that's certainly a problem that with respect to the overall user community. For example, I had this experience myself. 2 years ago, I bought a new hard disk, and when you look at the reviews, then between 50 and 20% of the reviews say this hard disk broke or had a major technical flaw. And I just don't believe that they have such a low output quality and a bad final control. This is just due to the effect that many users, if they're just satisfied, they will not write a review. But almost every user who experienced a failure will write a review and enter it because the user is angry about this product. And so the negative opinions are also a bit overrepresented. And I think, well, now in this specific hotel case, may be different because they try to get reviews from their users, and maybe they because they also know who actually booked the hotel, so they are able to, if they find out that, so they certainly also have some experience, if they find out only 30% of the actual users answered and submitted their reviews, and then maybe they also have tricks for downweighting the negative reviews. So so maybe that in this specific case it looks different, that they try to get a more objective picture.
The other thing that I was curious about is that many of these things, I mean, now that NLP is improving a lot, it's seen as like natural language understanding type of thing. Yeah. So with these kind of logic rules that base, have you thought or you tried to use them for some kind of natural language understanding models to make them better in their job using all the different kind of rules that you basically build up every time, so that you find a contradiction, you can reinforce this kind of information also for some narrow models or any type of different model. Does it make sense?
Well, we see these NLP models more at the beginning of the pipeline. And so we just take their output as our input, more or less. And since we are also focusing on aggregation, different texts. So I would say I cannot see into what extent our output could help them in the methods they are developing, as long as they also do not address the issue of aggregation. There have been some works already 10 years ago or so. There was a startup company, they tried to summarize the Amazon reviews. And for them, for example, our output might be helpful.
Yes, I was curious about one thing about contradiction. Very interesting. Yeah. So, going back to the example of using with or without sugar, that sense, suppose that you have 50% of reviews, good reviews that say, okay, this muesli contains sugar. Yeah. 50% of positive reviews that say does not contain sugar. So it's not about the quality of the item. Yeah. Have you ever checked about the distribution of the scores in these contradicting situations where you have a negation, it's contradictory, but it's either positive or negative in any way. So contradictions does not affect the score.
Yeah. No, we haven't done that, and we have to think about that. To what extent this really plays a role. Also, so the weights that I showed, because the weights of the 4 truth values, they sum up to 1. You only need coefficients for 3 of them. But of course, it would be pretty straightforward to find out what's the weight of inconsistent that results from that. But, we haven't looked at that yet. So, that's certainly a point we should do. I have to tell my student he should do that. He started writing his thesis, and so he should include that.
Thank you.
Any other questions?
No.
Sorry.
So I assume there's a correlation between the quantity of information that you have about a specific item and whether there are more contradictions or more missing information. So I was wondering, have you checked if this is in fact true, and adding a few reviews means also that you have more missing information or more reviews equal more contradictions? And if so, have you thought about a way to adjust your formula for different groups of items?
No, not really. That's another correlation we should look into. Yeah, but in the current situation, it's just we do a regression and that's it. Take it or leave it.
Okay, so I also got a question about the four-value logic,
Yeah.
and the traditional logic. I mean, it improves the indexing and the performance.
Yeah.
I guess because it was separating the two cases, unknown or consistency.
Yeah, and it has an explicit model for combining the truth values.
Exactly. But this was not well understood by your users, if I correctly got it. So
Yeah.
how can you, why they were not understanding and what is possible to do?
No.
Or
Yeah.
could it make sense to, after everything, remap into two-value logic so the system works better, but the users see something that they are.
Yeah,
more
in
familiar
principle,
with?
as I said, we didn't perform a user study for that, but in principle, I think what we could show to the end users is just something like that, or only condensed versions, only the positive reviews or the strongly positive reviews on this aspect, or the strongly negative reviews on this aspect. So first, I think first users need to understand that that it might be positive, that there are different aspects and positive and negative statements of aspects. And maybe then after some time they might also understand the concept of contradiction.
Yeah, I mean,
One step after the other. It's like this issue of this empty query I talked about, that in the beginning of the web, the users didn't know about filling search boxes. They just clicked on the submit button. That was the thing they had to learn. If there is a box, type in some text you're looking for.
yeah, because this is a little bit worried. I mean, nowadays they always talk about explainability in AI, whatever, which means making sense of why you see some results in a way than another. This is not it's not super complicated abstract features or whatever, but if it is already difficult for the user to get it, or it does not explain anything because it puts them into trouble. So what are we promising with explainability?
Yeah, of course, explainability always has to be adapted to the user group. Is this an explanation for the end user or for the expert who wants to understand what the system is doing and improve the system? So I think we need different types of explanation.
Okay, thank you very much. Any other questions, comments? All right, so let's thank Norbert. Oh, and we're done.
Okay.
Thank you very much, Norbert. We have 6 people, 3 to 6 people, and
okay.
Following us.